So now we're going to use our calculator to make a regression line. Okay, and so first thing I want to do is, actually the first thing I want to do is I'm going to go to mode, because I always forget to do this. Go to mode. I'm going to go down to stat diagnostics, and I'm going to make sure they're turned on. So if they're not turned on, I'm in trouble. So they're on, so I'm going to go to their second mode to get out of there. And I'm going to go to stat and then press enter. Okay. I'm going to be dealing with L1, L2. I'm going to go to the top with L1 selected. I'm going to press clear. I'm going to press down. With L2 selected, press clear, press down. I'm going to put my X values in L1. So my X values in L1. And my Y values in L2. Whoops. 30, 35, 40, 48, 56, 60. Okay. So my X value is in L1, my Y value is in L2. Now I'm going to press stat, hit the right button for calc, and I'm going to go down to option 4, linreg AX plus B. My X list is at L1. If you don't have L1 there, you press second 1 to get in there. My Y list is L2 at second 2 if you need to get in there. Leave that blank. I'm going to leave this blank, and I'm going to calculate. Okay. So I get some data here, and let's talk about what this data means. It's y equals ax plus b, and they give you the values of a and b. So all you're doing for a is you're plugging in these values of a and b into that equation. I'll go 3 decimal places. So it's going to be y equals 0.342x plus 20.404. Okay, now a very nitpicky thing. I do teach statistics, so I kind of sometimes when you do a regression line equation, they'll put a hat on the y. That means the predicted y. So you could put the hat on there. If you don't put the hat on there, I'm not counting you wrong, okay? So don't feel bad about that. Next, determine the correlation coefficient. The correlation coefficients are, so the correlation coefficients are, and so R, I'm going to put squiggly equals because I'm rounding here, is 0.994. Now, R squared is called the coefficient of determination. We won't talk about that much for linear regression in this class. We talk about that in statistics class. Is this a very good regression? So you're going to look and see, how does 0.994, is that weak, moderate, or strong? Okay, and so you look at 0.994, it's close to 1. So the closer it is to -1 or the closer it is to 1, the stronger it is. And if it's strong, it's good. So is this a good regression? Yes. You could say because the correlation coefficient 0.994 is close to 1, which indicates there is a strong relationship or association between the ages and heights of 7 children, or ages and heights of children. Let me, I'm going too fast here. What this means is that as age increases, the heights of children increase. So there's a strong relationship. The bigger the age, the bigger the height, which makes sense. So we're proving there's a strong relationship between the two variables. Now we're going to talk about interpolation and extrapolation, and we're going to talk about that. I did not mean to do, I apologize about this. I did not change these. So I'm going to have to change these. Predict the value of for a child. Let's say a child that is 80 months. So let's say a child that's 80 months. I'm going to wing this here. For a child that's 80 months. Is this interpolation or extrapolation? So first off, is 80 in between my values of x's? Is it in between 16 to 120? Yes. So this is interpolation. Okay. Now, how do I do this, I'm going to put 80 into my equation. So I'm going to put 0.342 times 80 plus 20.404. So all you're doing here is you're putting this value into your equation, okay? And you're using your equation to make a prediction. If a child is 80 months old, how tall would you expect them to be? Okay, and this is not a perfect relationship, but it just gives you an idea. 47.764 inches. Okay. Now let's predict the value of a child who is 200 months. Now it's 200 in between 16 and 120. No, this is called extrapolation. So now extrapolation in statistics land is frowned upon. It is not a wise practice. So they do not recommend doing extrapolation. This is something that statisticians talk about is not smart to do, and I'll explain why here in a moment. 88.804. I'll go off in the weeds here. Okay, why is this not smart? Let me break it down. 200 months, how old is that? That would be someone that's between 16 and 17 years old. So someone that's 16, almost 17, okay? Now, 88.804 inches. Let's look at that. That would be how many feet tall? That'd be 7 feet tall. So what this model is saying is that whenever you turn 16 or between 16 and 17, you're going to be around 7 feet tall. What's the problem here? Well, the problem here is this growth model is just for children. But do you keep this same linear, like this strong growth model as a child as you do as you go into your teenage years? No. You see, you have a point where you plateau, and then you maybe spike up a little bit, in the puberty years, and then you kind of stop, okay, growing. So this model extrapolation is not good because this model cannot predict. We can't necessarily say that the values beyond this values of x's are going to continue. This trend's going to continue. So we can't guarantee that trend's going to continue. So extrapolation is not a good idea. Interpolation is usually good if the correlation is strong.